Hi folks, and welcome back to Physics with Captain Rod. I'm making this video to help you out with your homework here, and we're going to talk about this one here. An insulating sphere with a charge Q uniformly distributed throughout its volume. So this is a volume problem. So the first question down there that says, what is the charge density? So your volume charge density, it's usually denoted with the letter rho here, right, is the total charge divided by the total volume. You can do that if it's uniformly distributed. If it's not uniformly distributed, you can still work it this way, but you need to understand what you're calculating is an average charge density that can vary throughout the volume. But in this case, this is uniformly distributed, so all you need to do is take the total charge, right, and we're going to use this to represent that, and divide by the total volume. Now, this is a sphere, and there is a formula for the volume of the sphere. I'm going to let you either look it up or hopefully you know it, or I just got done making a video about volumes of common geometries. So look up that or watch the video, and that should tell you how to do this. You'll get an expression here, not a number. Now, let's see, draw Gaussian surface through P. Okay, so So what you're going to do is you're going to draw a Gaussian surface that goes through this point right here, the outer edge. I'm not going to do that for you. I want you to do that. And you typically draw a surface that mimics the geometry you're dealing with. So your Gaussian surface will be spherical in nature. And then label its geometry. It should have a radius equal to that distance. And I would label that with a little r. I like to use capital letters for things that are constants in problems, and little letters for variables. I would label that with a little r. That's a pretty good way to do things. Let's see. How much charge is inside your Gaussian surface? So if you take your charge density, the expression you have, and keep in mind that that's a number that has units of coulombs per cubic meter. Then you multiply by the volume of your Gaussian surface. Right? So you're going to need an expression for the volume of the Gaussian surface. And you'll have an expression now for the charge inside of that surface. Let's see, write out Gauss's law for your surface, find the electric field. So remember, Gauss's law is this, that the total flux through any surface, which is the sum of all the EA cosine thetas, equals 4 pi k times the charge inside the surface. So I guess I already did this for you. Okay. Now, as far as finding the electric field, draw a few different normal vectors on your Gaussian surface and ask yourself, what is the angle between the electric field and the normal? That's going to tell you this. Next, ask yourself, is the electric field constant everywhere on your Gaussian surface? And think about the symmetry of the problem. Right? Is there any reason for the electric field to be, if I came out here the same distance here, or if I came up the same distance here, or down here the same distance, is there any reason for the electric field to be different at those locations, or should it be the same? And if your answer is, I believe it's the same, that means it can come out in front of this summation. And this should read the sum of all the areas, right? And I'll let you think about finishing that. So that should be just about done there. That should be enough to get you through that problem, hopefully. Have a great day.